Alright, here we go. Starting with perpendicular bisector. Today, as we work, we're going to be working our way up and down to see that relationship between the term and that thing there. You might want to use a ruler today as you draw some lines. I'm going to use a ruler because I like my lines to be nice and straight. You should have those small rulers in your bins. And then I'm also going to be using purple and green today as voted on by the class. Alright, here we go. We're going to start with perpendicular bisector. So I'm going to zoom in here. Alright, perpendicular bisector. What does it mean to be perpendicular? Good, crossing each other at 90 degrees. And what is bisector? Through the middle. Look at you go. On your game today. Alright, so it intersects a side in the middle at 90 degrees. Alright, on the top, I'm going to be using purple. So first thing we want is we need it to be in the middle of a side. So on that triangle there, I'm going to find the middle point there. I'm just going to estimate the best I can to make it a midpoint because I want the middle of the side. Alright, and can I show it to my reader that that's exactly in the middle? Yeah, the little dash is good, because if it's in the middle, what do we know about the two parts that it makes? They're congruent, they're the same. So I can do my little tick mark here, little tick mark here. For some reason, I think it looks better when I do two tick marks, so I like to do 2 and 2. But you can do 1 and 1. And then it's going to go up at 90 degrees. So when we draw that side, we want it to go straight up at 90 degrees. So how can I show that that's at a 90 degree angle? Box. Good. You guys are crushing it. What? Said you are crushing it. You are crushing it. You're doing good. No, I said you are. No, it's not. No. There's some freshmen in this class. Yes, there are. You can't say no. It's a fact. There are some freshmen in this class. Alright. Intersects a side in the middle at 90 degrees. That's our perpendicular bisector. Alright, we're actually going to jump down to circumcenter. So we're going to be working our way up and down today, not across. So remember, circumcenter is made of all the perpendicular bisectors. Okay, so we're underneath circumcenter now. Had trouble focusing this morning. Made of all perpendicular bisectors. Alright, so if I know it's a perpendicular bisector, I see that we have all those 90 degree angles. But it also tells us that that 90 degree segment is in the middle. So since it's in the middle, you guys said like KJ and KG. What do we know about that if K is in the middle? this side is going to be congruent to the other side. Because K is a midpoint. It's in the middle. And then we see it's at that 90-degree angle. What else do we know is a midpoint? L. So this side is congruent to this side. And what else? M. Good. Remember, why do we do separate amount of tick marks? Like, why is this 1 tick mark, 1 tick mark? This is 2 and 2.
Order.
Kind of with order.
They're not showing as all of them.
They're not all the same. Yeah, this one and this one aren't the same, but I wanted to show that this one is the same as this one. So those get the 2, saying that these are the ones that match. These ones match, but they don't necessarily match across. Good. All right, what we know about a circumcenter is that it is equidistant from each vertex. Okay, it's equidistant from each vertex. So as I look at my circumcenter here, what's the point that is the circumcenter? N. So from N to each vertex of that original triangle is going to be congruent. So I'm going to do N to H is congruent to what else? Not N to K. K isn't a vertex. N to J. J is a vertex of the triangle. And G to N or NG. Yep. Good. So those are all the same. I'm going to write that down here. So N to H is congruent to N to G, which is congruent to N to J. Now, circumcenter, remember that prefix circum means to circle, like a circumference. The reason why this is called a circumcenter is because all of the triangle end up on the circumference of the circle. It ends up on the outside of the circle. So if I draw a circle around this point, what ends up happening is it hits all 3 sides. That was a terrible circle. There we go. That's a little bit better. Okay, you can draw that nice and light. That's not like the big part of what we need to remember, but that's why all 3 end up being the same, is because when we draw that circle, it hits all 3 of those points. And that's why it's called a circumcenter, because those points are on the circumference. Okay, so if you want to draw that circle, you can do your best you can. Mine was a little rough. I did way better period 1. I did. Look at my period 1 drawing. And we used purple, so it's better. See, look. Did better.
The lines aren't as defined.
Okay. Wow. Oh, well. All right, here we go with the next one. We're going to jump back up to angle bisector. So I'm going to close up circumcenter and perpendicular bisector. All right. What does angle bisector mean? An angle that bisects. It bisects an angle, so we're going to intersect an angle. And bisect means it's going to intersect where in the angle? Right in the middle, exactly in the middle. I'm going to jump back to purple. Alright, so what's going to happen when we draw this? I'm going to draw an angle bisector of this top angle here. Alright, when we draw that angle bisector, I wanted to cut that angle about in half. So I want to think about this whole angle, and I want to rotate my ruler so I can get about halfway through that angle. If it's not perfect, that's okay, because we can show our reader that. You guys. Oh my gosh. Oh, just blame the other two. Communication is a two-way street. You're listening, so they keep talking. Stop listening, people will stop talking. Sometimes. Not always. Alright, so it intersects an angle in the middle. So how do I show that this was in the middle of this original angle? Kind of like dashes. It's not 90, so we don't want to use a square. Instead of dashes, how do I show that angles are the same? The little arcs, the little swoops, yeah. So this side here is congruent to this side here. So we do those little swoops going across. If you want to, you can do 2 swoops. If that makes your heart happy. So I do 2. I just think it looks nicer. Like 2 little bracelets going around the wrist. Alright, that brings us to an in-center. An in-center is created by all of the angle bisectors. Okay. So in-center, going down to this one now. In-center is made of all the angle bisectors. So we can mark that up because we know at each of those vertex, at the X, the Y, the Z, we know that it cuts that in half. So up at Y, I'm going to mark that DYG, this side. That angle congruent to GYE. What other angles can be congruent then? Good. GXF or DX? What did you say? GXF. So this bottom angle. No? You said GXF, didn't you? Yeah.
No. Yeah, that's...
Oh. Pretend you said Z. It was covered up. I just pretended. Okay. I'm going to do this one first because I accidentally screwed up. Sorry. You can do it the other way. My bad. I was so confused why you were saying D. I was like, no, it's E, teacher. I don't need to know my letters. Alright. So these two will be congruent. And then like Xavier is trying to tell us, GX will be congruent to DXG or DXD. And same idea, we're using different amounts of those arcs to show things that are congruent to each other, but it's not necessarily that they're all the same as each other. Okay, what we know about an in-center is that it is equidistant from each side. Is equidistant from each side.
Remember, equidistant means it's the same distance from each side, so that means all of those segments are congruent with each other. They'll all be equal.
So from our in-center G, if I go to a side is that 90-degree angle. That's why you see those 90-degree angles, is because it's saying this is the shortest distance. So from G to E will be the same as G to D, which will be the same as G to F. So G to E is congruent to GD, congruent to GF. Alright, part of the reason why this is called an in-center is because this time the circle is going to the triangle. Where before, in the circumcenter, the circle went around the triangle. This time, the circle goes inside the triangle, so connects the E to D to F, back to E. There we go. My circles are just a little off today. There we go. Crushing it. Relatively decent circle. Not great, but it's okay. Okay, so the circle goes inside the triangle, and that's why these are all the same, because these are all the radius of the circle. From the center to the outside of a circle is all the same distance. Alright, next up we have median. Median we talked about yesterday. Does anyone remember what is median? What is it kind of? Middle. So it's the middle of a side, but where does it connect to? To the opposite vertex. So middle of a side.
What's another word for vertex? Yeah.
So middle of a side to the opposite vertex. So if I start with the middle of the side, let's find the midpoint again on this bottom. Do the best you can just to estimate about where the midpoint is. Okay, to show our reader that that's exactly in the middle, we know if I cut it in half, what happens with the two parts. They're congruent, they're the same. Good, so we can use that tick mark, tick mark. And then I connect that midpoint to the opposite angle, or the opposite vertex. So do I want to draw it to the left vertex, go across, or go to the right?
Think about what might be the opposite angle.
Yeah, go across. I want to go through the triangle. And if you think of that word median, median kind of means to go through the middle. So we want to go through the middle of the triangle. So I'm going to connect this opposite corner to that point. A centroid is going to be made out of all of what? Do you think? Medians. That's why it's below medians. It's because it's made out of all the medians. So a centroid is made of all the medians. Oh, you can't see that. Sorry. So because it's a median, we know it's the midpoint, and we can mark those segments that are the same. So in our triangle, which one is a midpoint? What point? D is a midpoint, and F is a midpoint. Alright, so we're going to talk about that centroid theorem, which I always like to redraw. At one end of those medians is a vertex. Alright, come back after lunch because we are going to finish this short group practice that we'll work through. Alright, here we go. So this is made of all of the medians. And so when you draw this picture of this median, on one side we have a vertex. On the other side we have the midpoint.
It is not actually. Tell me why. You want to use the bathroom.
Alright. Okay. Let's just not worry about people using the bathroom and just do our notes. Alright, so a vertex means the corners of that triangle. So we're looking at A, B, and C. Those would be the vertices. What would be the midpoints? Good. D, F, and E, or D, E, F. Okay, is the centroid closer to the... or closer to the midpoint? Midpoint. Good. Layla, you can do this. Okay. You're literally talking so much. Alright, so our centroid is closer to that midpoint. Does anyone remember how we break that up into what part and what part? Good. Our smaller part is just X. And then our longer part ends up being 2 times X. It's 2 times that amount. Alright, we have one more new vocabulary word, and then we're going to do some tips, some things that are important for us. Alright, next up we have altitude. Altitude we have not done yet. However, it's part of this chapter. We don't really talk too much about altitude until chapter 11. But somewhere someone said, it goes in this chapter. I disagree. But we'll just do it today anyways because we have to. Alright, an altitude connects an angle base at 90 degrees. Connects an angle to its base at 90 degrees. Alright, top angle, the 90 degrees means that it's just like it's falling straight. So when I connect that angle to its base, I just want to go straight down that angle. Straight down. So it's like the height is sometimes we call the altitude height. And then it creates that 90 degree angle on that part with that opposite side. So it's like it just drops right down from that top. Alright, so for takeaways, you might want to write some things that make sense to you. If you want to remind yourself what a midpoint is, if you want to remind yourself what an angle bisector is. A couple of things that I'm going to write with takeaways is when I see like measure of angle, I don't know, A, B, C. Or when I see just 2 letters like B, C equals. In these problems, I want number answers.
So that means we're looking for the degrees or we're looking for the length.
So when we actually see that measure, that M, that means we're looking for how many degrees it is. A little degree sign there, I guess. Or if we see a segment without a line above it, we're looking for the length. How far is that? Okay. A couple other things that you might want to remind yourself of is that the three angles add up to what? 180. That might be something you need when you solve these problems. Alright, when you see that box, most of you know this, so if you don't want to write this down, that's okay. If you don't know it or want that reminder, that box means what degree? 90 degrees. Alright, if I have an angle with those little arcs, those arcs mean that they are this congruent, which means that they are the same, right? So same measure. And you might want to remind yourself that what the tick marks mean. Oops. Make that a point. Do like a tick mark and a tick mark. That means that these are the same length. So if you have not glued this in yet, you can glue it in. You're going to glue in the back side, the part that's all white. So I'm going to stop it for a second just to show you. You'll glue this side, and then it'll be glued into your notebook. Doesn't matter which way you glue it. It's up to you. If you want a title for the page, the title would be 5-1 and 5 vocabulary. We're going to do a Nearpod together. What? A Nearpod? Just like a thing that we work on through together. Alright, 5-1 and 5-2 vocabulary, and then go ahead and glue that in where it makes sense to you.
Once you glue that in, you can keep your notes on your table, but take out your computer.
Alright, on your computer you are going to go to a different website than Schoology. You're actually going to go to join.nearpod.com.